Okay, folks, so we're moving on to the optimization content of this section. And first of all, let's talk about how you recognize an optimization problem. And we'll have to dig up a little bit of English for this. We call certain adjectives superlative adjectives if they describe the highest amount or the largest amount or most extreme in a particular field. So for example, we might say that somebody runs fast, somebody runs faster, and then the superlative is that somebody runs the fastest. So these types of problems, optimization problems, are ones that are asking you to find the superlative in these story problems. So you're going to be looking for the biggest, the smallest, the cheapest, fastest, slowest, most expensive, etc. What these types of problems are actually asking you to do is they're asking you to find the absolute maxima or minima on a particular interval. Okay? And we know by the extreme value theorem that if our interval is closed, then we'll definitely achieve our absolute maximum, absolute minimum, either on the endpoints or somewhere in the interior. So these are the types of problems you want to deal with. Just for fun, I've given you an example of sort of what you would see as typical algebra problems alongside typical calculus problems. So you can read through number 5. I'll point out number 6. Number 6 says, suppose an object's velocity is given by this velocity function here. In college algebra or in an algebra course, you might have seen this question. What is the object's velocity after 8 seconds? That's simply asking you to input and find the particular velocity when the domain value is 8. A much more sophisticated problem is this calculus optimization problem below it. What is the object's velocity when it's traveling the fastest? And we see the word, or we see the superlative adjective there, fastest. That's telling us that we want to go ahead and find the global maximum on the interval for which this function is defined. Okay. So there really is no new content in this section. Rather, all we're going to be doing is identifying where the absolute maximum and minimum occur on story problems. Initially, it won't be, for some of these problems, it might not be too hard to come up with the function. Where these problems get hard is actually not in the calculus, but in coming up with the function that we want to optimize. On the next page here, I've listed the steps for optimization problems, and I'm going to illustrate those steps by way of an example in the next video.